In this video, we're going to look at conditional and absolute convergence of a series. And I have two background videos. Background video 1 is a series of real numbers, and BV2 is a Cauchy sequence of real numbers. So if you're not familiar with either of those, I'd recommend going back and watching it. Now, the definition of an absolute convergent series is this: a series A of n is absolutely convergent when the series of absolute values converge. That means you take the absolute value of each term, add them up, and it is finite. Then we have an absolute convergent sequence. Conditional convergence is a series AN converges but is not absolutely convergent, and it's called conditional convergence. So here's the theorem we're going to prove in this video, which if a series is absolutely convergent, then it is convergent. And so let's look at this. So if we let S of n be the partial sum of AN, and let Tn, so this is a sequence, Tn, be the partial sum of the absolute value of AN. You know, the series of absolute values. Okay. So since Tn is convergent, that's by definition, since the series is absolutely convergent, then the sequence Tn of partial sums is convergent, and it is a Cauchy sequence. Then that means they're given an epsilon greater than 0, there exists an n such that when m and n are greater than that n, that the difference between the two partial sums is less than epsilon. So that's the definition of absolute convergence. And so you'd go back to BV2 to look at Cauchy sequences. So then if we look at this partial, the difference of these partial sums, Sm minus Sn, remember that S is dealt with it's a sequence of numbers, well, it's the partial sum of An. So if we look at this difference, which means, remember, this is adding all the sequences up to m, and this is subtracting all the terms, you know, from n down, so that only leaves, you know, n plus 1 up to m. You know, we're adding these terms. But by the triangle inequality, the absolute value triangle inequality, we know that if this is less than the absolute value of each of those terms added, but adding these absolute value terms is really the difference between the partial sums of Tn, Tm minus Tn. But because it's a Cauchy sequence, it's convergent, we know that that's less than epsilon. That's by definition. So that says that the partial sums of our sequence An is a Cauchy sequence. So this implies that Sn is a Cauchy sequence, which implies that Sn is convergent. And since our partial sums is convergent, that implies that the series An is convergent. And that's what we wanted to show, that if we have an absolutely convergent sequence, then it's also convergent. Well, that's all I have for today. Hopefully you enjoyed that. If you did, please like the video, subscribe so you don't miss the next one. Thanks. Bye.